Hey kids, bet you're wondering why we're looking at a picture of a swimming pool, right? In the middle of winter. Well, it is time to do what we call rate in out problems. So, a couple of years ago, man, probably maybe about 7 years ago by now, or maybe more, gosh, um, we started to see some problems on the free response that we hadn't seen before. And it wasn't that the kids didn't know the math of what the problem entailed, but they hadn't seen a question presented and the language used in the problem. So a lot of people came out of the year in, I don't know, what was it, 2010. So I guess, oh gosh, so I guess it is like 10 years ago. So 2010, they came up after the AP exam saying, "Oh my God, Miss Getz, Mr. Davis, no one knew how to do the snow problem. There was some problem with Janet shoveling the snow." So we saw it. We said, "Oh yeah, we better start incorporating questions like this to practice with." And so there's been every year a rate in and out problem since 2010. So we want to make sure to go over these. So we're going to do the swimming pool problem with you today. And then we're going to assign a couple of them for you to try, a couple of other ones for you to try for homework. And then we will go over another one in our live session. So the swimming pool problem was in 2010 on the AP exam. So here are the pieces. Firstly, I want you to recognize that you're given a table. You have been taught how to estimate both derivatives and antiderivatives from tables. You don't know what this table represents at first. So here's the above ground pool, gives us some dimensions, says it contains 100 cubic feet of water. So I have a cylinder, contains cubic feet. Units are going to be really key here. At time zero, there was 1,000 cubic feet of water. Well, look up here at this table. At time zero, it says 0. What the heck? So these values cannot represent the cubic feet of water. It is talking about time going from 0 to 12, check and check, right? 0 to 12 in time. Water is pumped in to the pool at a rate. P of t is the rate in. And the units on rate in are cubic feet per hour. That's important. Rate in. So at time zero, there's no water being pumped in, but how much water was there to begin with? Right? 1,000. Pumped in at a rate. P of t is a rate, which means P of t is a derivative. You're looking at a derivative. Values of a derivative with units cubic feet per hour. During the same time interval, water is leaking out from the pool at a different rate, also in cubic feet per hour, but R of t is also in cubic feet per hour and is a derivative, but it is a rate out. Right? So there is a leak in the pool, started with 1,000 cubic feet of water. There is water going to be pumped in, but there is also water going out at the same time. Notice they do give you the formula for the volume of a cylinder. Hopefully you don't really need it. But part A here says use a midpoint Riemann sum. So part A is MRAM. To approximate the total amount of water. Total amount of water is just cubic feet, right? It is not cubic feet per hour. So if you have two rates where their units are cubic feet per hour, how do you go from rates of cubic feet per hour to just cubic feet? Integrate. So you are going to integrate and you are going to approximate the integral from 0 to 12 of what? Approximate the total amount that was pumped in. Who is our in function? Right? P of t is in feet per hour, cubic feet per hour, excuse me. And dt is in hours. So that's going to cancel out. And that is going to give me cubic feet. Check. That's what I wanted. Now, I don't have a function to integrate. They're asking me to approximate it with MRAM. So they want 3 subintervals of equal length. So hopefully you can see that delta x is what? 4, or delta t. Right, that's a width of 4, so I'm going to have 4 times the midpoint. 46, 57, and 62. Make sure to put your units on your answer. Here are the rubric points for that. This part of the question was awarded 2 points, 1 for the midpoint sum. So that means you needed to have this. And you could write it in a lot of different ways. You could write 46 times 4, 57 times 4, 62 times 4. You could have written 46 as P of 2, and then plus P of 6, and then plus P of 10. There's lots of ways you could have written it, but there is only 1 point awarded for this sum, and they don't do half points. So if you did anything wrong here, you lose that point. Then there's 1 answer point, and the rubric has the answer as 660 cubic feet. That's worth 1 point. So if you just have 660, you're not going to get this answer point. Now, if you had made a mistake in here, let's say your delta t, you either forgot it or you wrote 2, or one of these is wrong, you would lose your midpoint sum point. But as long as this value matched and followed from your work to the left, you would be awarded, and you had your units, you'd be awarded this 1 point, and they would call that a follow-through point, right? That's if you made a mistake, they could see here. All right, point A, done. Using integration on a derivative to get cubic feet when the only information I was given was cubic feet per hour. Part B, calculate the total amount of water. Total amount of water that did what? Leaked out. Leaked out. So who is our out? That's not P of t. This is going in, right? This is our rate in. Who is our rate out? Yeah, R. Do we R, though? Remember, R of t is a derivative. It's a rate out. I want to know the total amount of water. I don't want to know the rate. How do I go from cubic feet per hour to just cubic feet? Integrate. They want 0 to 12 hours. I'm going to integrate R of t dt. And this was calculator active. So I don't need to write out and actually integrate. And at this point, of course, you don't know how to integrate. So you would have to do f and int, right? So I would math 9 this, and I got an approximation that AP lets me say equals to, as long as I write at least 3 places past the decimal. So this was part B, and part B had 2 points associated with it as well. 1 point for the integral. You cannot write calculator notation. You can't write math 9 or anything like that. You have to write the integral notation. They're going to expect to see the bounds 0 to 12 and the function in here. If you actually wrote the function, that's fine too. If you forget the dt, they're not happy, but it won't cost you the point. So try to get in the habit of writing the dt. Remember, the integral notation is the integral sign and the dt or dx or whatever. Both of those, that together means integrate. And then again, 1 point for the answer, and the rubric has units with the answer. So if you didn't include units, you don't get that point. Now, they do keep track. If you lost a units point in part A, they won't ding you again for units in part B. You can only lose a maximum of 1 point per 9, right, per each separate problem for units. And it's the same with rounding. You can only lose 1 rounding point for every 9-point AP problem on free response. But why would you give up those points, right? How terrible would that be if those were your border between a 4 and a 5, right? All right, part B, done. Part C, use the results from A and B, and oftentimes free response, part C and D, not 100% of the time, but often refer back to what you've done in earlier parts. Use the results from part A, and remember part A is where we approximated volume going in. Part B is where we approximated over 12, the water leaking out. So we want to just approximate the actual volume of the water, which is again in cubic feet, not cubic feet per hour. But at the time t equals 12. At the time t equals 12. So what have I been doing? From 0 to 12 going in, we used MRAM to approximate that value, right? So that's going in. Subtract off what's coming out. How do we figure out what's coming out? We integrated from 0 to 12 R of t dt. And remember, these are accumulators, right? So it's the total amount of water that went in over the 12 hours, total amount of water that went out over the 12 hours. So when you get those together, you get the total amount of water in the pool, right? Well, let's see. This was 660, right? And this was 225.9594 cubic feet. So all I'd have to do is subtract those, right? Now that will get you partial credit, maybe. Also, don't forget it says round. This annoys me. Round your answer to the nearest cubic foot. They keep telling you round to 3 places past the decimal, 3 places past the decimal, unless inside the problem it tells you otherwise, and then one problem does. So annoying. Anyway, what's wrong with just subtracting these? If I just subtracted those, I would get 434.406 cubic feet. Why isn't that the right answer? Go back and look at the first slide. What did I highlight? At time 0, how much water was already there. Right? So I get 1434 cubic feet over the first 12 hours. This only had one rubric point with it, and the answer includes the interval. 1 point for the answer, and in the rubric, the answer is not for any of this. There's no work for any, because really you've already done all of this work, right? And you didn't get the 1,000, it was given to you. So there's only 1 point available, and it is for the answer appropriately rounded with the units and with the time interval. And you could say at the 12th hour, because that's what they said, or you could say over, after 12 hours. How you can say that anyway, as long as you refer to the time interval. Remember, I told you that. Reminded you to do that AP cares about that. All right, let's do the last part. Find the rate. Oh, well, that should be cool. I'm given 2 rates. This is the rate in, and R of t was the rate out. Right? Find the rate. Oh, find the rate at which the volume is increasing at t equals a. Well, wait a second. The water in the pool isn't the rate in and the rate out. What is the water in the pool? The volume of the pool at any time, right, is the integral is 1,000 plus the integral of the water going in minus the integral of the water going out, right? That actually gets me volume. But I don't want volume this time. I want a rate. So what do I have to do? Take the derivative of volume. Well, what is the volume? What is the derivative of sums or differences? Just, right? The derivative, the sum and difference of the derivatives. What's the derivative of 1,000? Nothing, honey. What's the derivative of the antiderivative? What's the derivative of the antiderivative? Oh, my Lanta. And don't they want to know that at what time? Find the rate at which the volume of the pool is increasing at time t equals 8. P of 8 is 60. R of 8, I just used my calculator. Right? Pretty cool. I found, oh, what's next? I've got that part. Find the rate. This is the rate of the water is increasing, which means the derivative is positive. Yep. At the time t equals 8. Done. But now what are they asking? What? How fast is the water level rising? How fast? What is that? What? Yep. You didn't expect it, but here it comes. Related rates. Oh my gosh. What? They snuck it in there, didn't they? How fast is something changing? That's a related rate. What do they want to relate? How fast is the water level? The water level, they want you to find how fast the water level. Right? That's where how do you relate? The height and the volume of the water. Right? Differentiate with respect to time. Chain rule. dv dt. What's true about the radius, though? The radius is constant, right? Take the derivative of h with respect to t, bring down the 1, copy over the h, right? There's really a 1 there. Bring down the 1, copy over the h, subtract 1 from the exponent, spit out the derivative. So dv dt is equal to 144 pi dh dt. The rate of change at volume at 8. What is the derivative of volume with respect to time at 8? Oh, snap. I found that, didn't I? So I have, that was the given rate. So dH dt is 43.241 feet per hour divided by 144 pi. And that was equal to 0.095 units. It's a rate, but it's not a rate of volume. Feet per hour. Whoa, that's crazy. Now, this was part D, and the red part was the second part of part D. That might be something that you tend to leave, right? If you're panicked and you're not sure and you still have 2 more long answer problems to go, you might leave the red part. So let's look at the rubric and see what. Let me erase some of that stuff. I don't want to erase it all. So let's look at everything that they would have given us, and then let's talk about what would happen if you messed up the last part. What happens if you sacrificed it? There was 1 point for finding v prime at 8. So 1 point right here. So I wouldn't have had to write out hardly. There's only 1 point for the answer, right? What is v prime at 8? Here's what it is. The next point was for an equation relating dv dt and dh dt. So you did have to recognize that there was related rates involved. You had to differentiate this, which I did erase. But if you had just written dv dt is equal to 144 pi dh dt, there's that second point. Your third point was finding the answer. And your last point was the appropriate units of cubic feet per hour here and feet per hour here. So if you had completely bailed on the red part, you would only get 1 out of 4 points for part D. So be careful. But notice that of these 3 points here, if you had just been able to realize that it was related rates, it was the volume of a cylinder, you've done a ton of these problems, this shouldn't have been too hard for you to do. And then if you didn't know what to do, but just put, hey, units, make sure you had units on this, and then make up some number and say, I don't know, something feet per hour, you would have gotten that point, right? Truth. I'm not lying to you. They are looking for anything that you're doing right. So this was the hardest part of that problem, as long as you did recognize that you had a related rates question to answer. Okay, related rates is tested a decent amount. All right, so that's going through the pool problem. And we will go through another problem live, but if you could try to look at the problems that we give you on the handout and see if maybe you can at least like pick it apart, use your factoring brain and try to figure out what is, what is the rates in and the rates out, what questions are they asking me, what are the units, would kind of be a good way to start. I will see you in our next live session.